In today's episode,
the application is not sending any traffic. So it's a problem for the server.
We go back to a time before automated troubleshooting.
It's like a lasagna of technologies,
Tech engineers had to rely on
Reset, reload, replace. So that's also
their wits and skills.
Do you want to understand what's going on? Or do you want to fix it as soon as possible? And I will mention AI, because of course, why not?
Welcome to Cisco Tech Stories. A podcast with real-life stories from real-life engineers. Your hosts are Nicholas and Tristan.
Hello and welcome to another episode of the Cisco Tech Stories podcast, a podcast where we listen to outstanding stories from our guests from all around the world. We're your hosts, Nico and Tristan, technical leaders in Cisco EMEA. Today we're welcoming Esther. Hello, Esther.
Hello, Tim.
Hello, Esther.
Can you introduce yourself a little bit? I think you joined Cisco along with a great group of grads, right?
I think so. So it was 2007, and I joined fresh from university. So that was my first, let's call it real job, because of course I had some summer jobs and I was working in the farm with my parents, but that was my first experience in the real world. And what an experience it was. So I think it comes up 17, 18 years that I've been working for Cisco in many different roles. Today, my role is sustainability lead for CX EMEA. I will explain a bit later what that means. But yes, I started in technical services, helping customers with the challenges that they had.
Nice. So I think that's the kind of story you have for us today, right? From your switching, routing background?
Yes. So I don't know if people realize when you start at technical services or TAC, as we like to call it, the learning curve is quite steep. So you learn very, very fast. You are kind of thrown into customer challenges. But then after a while, you learn how to troubleshoot, you learn the methodologies. So it becomes actually quite interesting. And one of the cases I wanted to share with you was a bit of an adventure because it started when I was actually sick. So I was pretty sick at that time, and the customer called me and asked me, could you help us with these issues? So I was actually not able to help them out. I was with fever. So I give them like a set of guidance. And the issue started very, very simple, a crash in the network. I mean, who did not have a crash in the network, right? But then, of course, what is interesting about the crash, there is not much you can do if you don't understand the process that crashed. And it's impossible to understand if you don't get the help from TAC, right? So that's what I asked them to do. Just, open a case, contact my colleagues in TAC, and then you can understand the process that is crashing. However, they had some other ideas. So let's say, okay, why don't we try to reload everything, reset everything, replace everything? I mean, not everything, obviously, the device that was crashing, but the 3 R's, right? Reset, reload, replace. So that's also...
Yeah.
That's a bit of troubleshooting trick that so we use sometimes. Anyway, but no, in this case, you cannot do that. You really need to contact TAC to understand the process that was crashing. And at that time, it was SNMP. And okay, we say easy peasy, SNMP, you remove the configuration and it should be fixed.
Disable your monitoring server, right?
Exactly.
You don't need it anyway.
Exactly. So then at that time, you would think, well, that would be easy enough. But what would happen is the device that was actually crashing was the firewall. And the firewall is the one that was providing also access to the internet. And then what people don't realize, and I'm not sure if everyone tests for, is when an application does not have maybe access to the internet or access to the storage or access to some of the ecosystems or the devices that they are using. So that what happens is that some of applications started misbehaving, right? And then you start to have like a lot of storms trying to get into the storage area. You had also some high traffic in the network. And then we were discussing about also a spanning tree, right? So when I started, I was really focusing on a spanning tree and understanding how the customers use the layer 2 network. And then normally layer 2 is very difficult to troubleshoot live. And this one was also one of these scenarios. When you start to have a storm or information that gets pushed to a storage very heavily, it's difficult to troubleshoot. But then what people will normally do is you store shutting down redundancies, right? So just to make sure that you come back to kind of normal traffic.
But it's difficult to troubleshoot because it's data plane, right? So it goes fast and you can't debug thousands or millions of packets, right? That's the main reason.
Exactly. And your network is down. So then normally what you would do, you need to follow up the whole loop and then find the source. But this is timely, it takes time. So it's actually easier, just to shut down. Maybe you start like with an access switch, or you start with some of the access switch, or literally you shut down or reload the redundancy path, and then it will break the loop, right? So I think that's one of the things, it's a balance between, do you want to understand what's going on and then, or do you want to fix it as soon as possible and try to move on. Then the risk there is that you may not understand what will happen in the network. So there is always a balance between kind of finding a workaround or really understanding the issue. And then in this case, we did not see a loop on the post-mortem analysis, but the team decided, well, we'll shut down the redundancies. They came back, or the internet connection was reestablished, and then the network was stabilized. But then I came back after a week of sick leave because I really had a big fever. So then you come back into half of the network. So we had two challenges. The first one was we had to understand what happened because, of course, we wanted to fix it and for sure put preventing measures so it will not happen again, because that really brought down the whole network. And then the next one would be making sure that the customer had the redundancy back. We really had everything down. And in this case was a data center. So we were working throughout the UCS server plus the Nexus. We had the MDSs, so the storage switches, and we also had the storage side. So it was really end-to-end troubleshooting. And it was one of, I think, the most interesting cases that I had. So in the one side, we had to ask ourselves what happened, right? So, and which information we had available. Luckily, Nexus, when we started, Catalyst did not have that many logs, but Nexus came with megabytes of logs, and then UCS came with gigabytes of logs. So you had actually plenty of logs to look into. That also, of course, it comes with a challenge. How do you correlate this information? I don't know.
Yeah. I may have a stupid question, but a spanning tree loop sounds like something that would start all of a sudden after someone does something, right? The configuration somewhere. Like it doesn't start by itself magically.
Well, it done. So, but just to clarify, this one was not specifically a spanning tree loop, just was doing the comparison. But so a spanning tree loop could actually start as well because one of the cables get just one direction. Yeah. So a cable could fail. Of course, there is mechanism for that. So you have, now I will forget about the feature, of course, but there is a feature that specifically checks that the link is bidirectional. Then the most, normally someone that it's in a meeting room that connects something that creates a loop. I think this is the most normal.
The classic one.
The classic, yes. Because also if you, again, you also have some ways to prevent this. So there is some mechanisms in the access ports, but of course not everyone has the due diligence. And again, we are speaking about, I would say 10 years ago or 7 years ago. So I think we have gotten much better on automation, controllers, monitoring, and also the logging to correlate the data. Has nothing to do with when I was on TAC. I think now the tools that you have, and I will mention AI, because of course, why not? But I think now the intelligence that you build, guys, in the technical services is actually quite rich. So you are able to correlate this information much quicker. In my case, this was, I think in Spain, I would say one of the first data centers that was getting automated so that you could deploy services, with a couple of clicks. So you would decide, okay, this is the type of services, just click it and it will be automated. But at that time, pretty much everything else was manual. So you had no controller for ACI, or you had nothing that will deploy your infrastructure for you, if that makes sense. So it was really at the beginning of these automations. So then, in this case, one of the questions was, of course, things do not break if something doesn't happen, right? So you need to find what is the starting point so something will break, because this is an infrastructure that has been working, pretty okay for like about half a year, maybe 9 months. The particularity was this, that it was really it was very dynamic. So VLANs would be configured all the time. New customers would be onboarded on the time. So it was not a static infrastructure. So in this case, we thought, okay, let's look into what happened the first 24 hours before this crashed. And one of the things that we realized, the firewall was redundant. So the second firewall just went down. I don't remember why it was. I think it was actually some hardware problem, but the firewall just went down. And that was actually the trigger of everything else. And, sometimes we don't invest enough time on maintenance or checking, simple stuff. If the console port is working, if we have the right configuration, if we remove some configuration that it's cleaned properly. And again, now with controllers and automation, life is much easier for the engineers. But at that time, a lot of that, you would create a script to do it, or you would need to do something manually as well. And then what would happen is that when you have an issue and you have some, I don't know how to say, but if you don't do the maintenance and the due diligence properly on all the ports and all the switches, there is always something that you will find when there is a big issue. So, suddenly you don't have access to the switch through the console port. Some configuration is there that you don't understand. You didn't have the logging enabled. So there is many things that happen at the same time, and then it just becomes from one simple problem, a firewall went down, to a whole network shutdown, right? So these kind of things are very interesting.
That's a classic. You have problems, and then, hey, do you have a syslog server to collect because your console is not working? Oh no, we didn't enable syslog on that one. Or, oh yeah, did you have a backup of the config? No, we don't have any. It's always when you have the problem that you notice that you're missing a few things.
Exactly. So I think this kind of due diligence, and I think that's where we as technical services are able to really help the customer to make sure that they go through all this due diligence, because otherwise a port that goes down, it can really spiral to really quite a lot of issues if we don't work with the customer to make sure that they go through all of that. And automation, I think, made our life much simple. At that time, I literally had to look for the timestamps, right? So this timestamp is actually the timestamp properly configured. Do they have NTP suite? Making sure that everything is aligned. Do they have any second of? And actually, in this one, how I realized that the switch went down is because all the ports connected to the switch went down. So I'm like, that's something weird. Suddenly, 7 ports went down. So what's happening? And then, we realized that this firewall was down. Another thing I think not everyone really sees, when we configure a network and you have all the syslogs, and new messages will always come, right? And you will have an error. You don't know if it's a high priority or not. It may be tagged as low priority, but actually it's very high priority for your network. So I think logs always need to be reviewed, because what will happen here is that there was a lot of high priority messages. And then just this one, they did not see, because there was maybe 100 every hour, right? So how can you check 100 high priority messages? So these kind of automations are very important that we do the due diligence. And then, of course, this track all the different issues. So after one day, the next firewall went down for the SNMP issue. So, and that was a very simple crash. And it was a really corner case when I think the redundant port was down. And that was trigger the crash, because otherwise, a crash would be quite a standard. So if A, B, and C happens, then the crash will happen. So you need to understand what is the A, B, and C. And the C in this case was actually this redundant link being down. And then when this happens again, like this caused that the applications did not have access to internet, and some of the applications they started to actually save information for what we could see to the storage very, very heavily, and then that also caused some instability on the storage side. That was actually solved with the two things: closing the redundancy and then making sure that the application had internet connection. But I mean, you can imagine this is like almost an art of correlating logs, understanding what is running here, what is running there, and the use of the end-to-end of the infrastructure as well.
So now you're pitching Splunk, right? Observability and having a good view into what's happening on your network.
Exactly. So when I start, when people try to understand what I was doing at the beginning of my career, I told them literally I was looking for packet lost. So you see, it's like almost like a courier. Where is the packet lost? And to have this kind of visibility, it's actually very interesting, but you still need to really understand, I think, deeply how the network works and so on, right? Because you need to make sense of what the data that you see in platforms as Splunk as well.
Yeah, in my experience, I think there's two phases in a problem. There's really one, problem isolation, and the reports you're going to get from your help desk or your users. Your users say application is down, then you have to figure out which servers are down and what is exactly happening, right? Because the reports you're getting are not what the problem is. So you need those. Now with controllers, right? ACI or Catalyst Center on enterprise, they're going to digest a lot of the alarms and messages for you to say this is probably the root cause, like with the major event happening in your network. And only then, when you have a prompt description, like, okay, this part is crashing or this part is having a loop or whatever, then you dive into the specific device and look into what's happening, etc. But you cannot do problem isolation if you're going to have to jump in every network device and go deep in the logs. Like that's going to take you forever. I mean, it's with today's network complexity, it's becoming impossible. So yeah.
Yeah, and especially if you need to do it real time, right? So for that, a lot of customers would say, okay, let's shut the redundancy or let's try to roll out a couple of things, see if it fixes before doing like live troubleshooting. So yeah, this kind of tooling, I think it works a lot. What I loved a lot in LAN switching is a lot of in the network, they will always say, let's say they will always blame the network, servers team, application team. The first thing it would be blaming the network. So I was actually doing a workshop for one of the customer. It was related to VPC Nexus 5000. And then, the team comes, you have an issue and so on. And of course, I'm from tax, so what can I do? I'll come to troubleshoot live with you guys. And then everyone was so stressed out. It's like, Esther, what are you doing? Why are you going to troubleshoot? It's like, of course. As core engineers as we are, and I show them like the simplest stuff. You go to the switch and you see if there is traffic coming in or traffic coming out. If there is no traffic coming in, the application is not sending any traffic. So it's a problem for the server, right? And you see like these kind of things. It's very funny how you need to have this whole end-to-end visibility, but sometimes the easiest thing is just to look into the interface counters, right? So it's a kind of a dance that we need to do during troubleshooting.
Yeah, it feels like many years back, it was always, you had the application people. I'm going to generalize, say, oh, it's a network problem. Then you have to say, no, it's not the network. It's sometimes your DNS server or it's like something else. But it was always a ping pong between 2-3 teams. But now with network complexity, I've been in incident. We have an incident panic room, and you have the firewall person. You're going to have the routing people. You're going to have the wireless folks. You're going to have the data center guys, and like everyone is staring at each other. And if you do desktop sharing, it's not going to happen. Like only one person can work at a time, and the problem could literally be anything. So that reinforces that isolation phase, where you need a team that who is able to pinpoint thanks to automation tools. And then you engage the right people in the right part of your network. But otherwise, it's just impossible.
Yeah, 100%. No, and I think it became very complex. And now, I mean, some issues could really have huge impact if we are speaking don't know about hospital. I mean, the other day, right? Like the whole, I think, aviation industry had to shut down for a whole afternoon just for an update of a software, right? So I think people start to understand the scale that we are working with when we speak about technology.
Yeah, I think it's the same in every technology. Like you in the past, you had the core technologies and like the nice to have technologies, but now it seems every technology is key because security is part of everything, and then even critical devices in hospitals, airports use Wi-Fi as well. We have planes connecting to Wi-Fi when they land, etc. So yeah, there's not a single technology that's just a nice to have anymore.
And not just that, but you also have everything is interlinked together. So all the technologies are interlinked together, and there are a lot of layers. It's like a lasagna of technologies. You have this mix of public cloud with private infrastructure. So all those small layers, in the past you would have a server directly connected to a router, but now you have a server that is running in a public cloud somewhere with a million routers in the middle, with layer 2 providers that's supposed to be transparent, but sometimes block packet, things that you didn't see before, which adds a lot of complexity. So we cannot do this analysis on our own. We really need to have automation and tools that help us finger point what's important versus what's not, right? Otherwise, you have to dig through gigabytes of logs, and you'll never find it in the right time.
Exactly. Yeah, especially if you are virtualization, because the counters will be also virtual counters. We don't have physical counters anymore. So then how do you know that the virtual counter, there is no error? I mean, physically, I think we were 99% sure, though I did see changing like the physical configuration of an ASIC in TAC. So you would put like the hexadecimal command directly to the ASIC to change the configuration. But with software, it becomes, I think, quite complicated as well. And I mean, the whole layers, I think when we started with the data center was already quite complicated, but with all the virtualization of the network and so on, it has become crazy. And now we will have also the added technology of the whole machine learning, the AIs, and all this stuff that I think it's going to be adding a bit more complexity also into the workloads of our customers. So let's see. Hopefully, also helping us, it's already helping us on the troubleshooting.
I want to ask a question because when we opened, you said you now work as a sustainability lead. To me, sustainability has often been a buzzword, right? Because it's nice to have, let's be green, etc. But I know you're not a woman of buzzwords, so can you tell us exactly what you're doing now?
Perfect. So I started to look into sustainability. Well, I didn't think. It's difficult to understand, I think, how us engineers can contribute to sustainability or to the conversation, right? And that was a bit my case 2 or 3 years ago. And as you know, I'm also very big on innovation. So I do design thinking, hackathons, and things like that. So I'm a bit like this weird engineer that likes the ASIC, but also likes the customer empathy map, if you like. So, and then we were starting to say, okay, how can we help our customers in EMEA on sustainability? We ran a hackathon, the Green and Blue hackathon. So we identified some of the challenges. And if you looked into sustainability end to end, it's very complex because you have the social aspect, you have the environmental aspect, and also the governance part. And then today, everyone is really looking more into the environmental aspect, just because the link to climate change and CO2. But the social component, especially for the data centers, is actually quite interesting as well. So I'll speak a bit more about this one. But then, we focus on environmental is the most important for our customers. So we looked into how can we help them first understand what Cisco is doing. So more and more customers in EMEA and worldwide, they are asking what are the commitments from Cisco, the net zero, what are we doing related to environmental stewardship, human rights as well, and so on. I think that is quite well documented.
That's mostly how devices are built, right? How our supply chain, how we do
exactly.
Things.
Yes. So, and then once if you understand what we call the scoping for Cisco, so the CO2 that Cisco generates, CO2 equivalent, emissions, greenhouse gases, there are different names, is divided in three different scopes. So one is directly what we produce, the second one is indirectly the electricity mainly that we consume, and then the third one would be our customers and partners. And you can have the numbers as well in our Propose report or CSR report yearly. So, and one part is the how we manufacture and transport the products, and then another big part is how our customers are using these products, and this is mainly electricity consumption. And then this electricity consumption has well, it generates CO2 depending on the mix of electricity. And here in Europe, we have actually quite diverse supply of electricity. So there are countries that are actually quite green. There are countries that do not generate a lot of CO2, but rely more on nuclears as well. And there are countries that the electricity mix, it actually generates quite a lot of CO2. But then anyway, what we realize is, okay, customers, I think in general, they really want to understand what Cisco is doing to decrease, the environmental impact during the manufacturing of these products. And then we want to really help them to make sure that they, well, first try to consume as many renewables as possible. So we will lower this CO2 impact. However, what is very interesting as well is energy consumption in general, because if you see the trend for energy on the IT equipment, I would say the traffic rate has increased quite a lot, but then the energy that we consume has is not lower, but it has not increased at the same rate, right? So I think we became quite efficient on the way that we are using energy. But we do know that we can be much more efficient. That being because some of our devices are actually more efficient and also more powerful. That being because we can help the customer optimize the infrastructure with energy efficiency features or actually optimizing the way they use the resources. We have seen quite a lot of customers that they would have ports that they don't use. This could be actually a security risk, but you can actually also save energy if you are reducing. So then, long story short, when I started on this role, my mandate, if you like, or my objective is to understand what we could do from a services point of view to help our customers on their sustainability journey. So that was quite broad because we really wanted to understand what was the top of mind of our customers. And actually what we realized that first, in the observability point of view, none of the customers understand how the devices are using electricity. First of all, it's really quite, I think, blind spot that we have today. So we have developed the capabilities to actually monitor and identify or understand how our devices are using this electricity. And then we have developed the intellectual capital to help the customer to optimize the use of electricity as well. I don't know if that makes sense.
I'm not sure I got what you mean in the first point. How the device is using electricity. Is that how much electricity is used by each device, or what is the breakdown inside the device? Like a switch needs X watts to run, X watt per port, X watts because you have this feature on, or like, I'm not sure.
Yes, so that's interesting because some of the new switches, you could actually get such a granularity on understanding even the ASICs. That's like for the 8000s, they even have this concept of watt per packet. So they really go very granular on the understanding how this is used. This is not applicable for all the devices at Cisco. The smaller switches, you will never have this kind of granularity. But then the older ones, you don't have that good visibility just on the energy that they consume. And you will know it when we try to monitor something, it will always come with a different structure. It may come with a different standards. So we had to understand first which is the standards, what is the data accuracy that the devices are providing to us based on the power draw that we have in the network. Also, the PSU has different, impact as well. So the power that you consume versus the one that gets to the device, you always lose a bit, 10, 20, 30, 40. So then you need to kind of correlate all this information. But then if you have a switch that is doing nothing, then this power is basically wasted. So how do you link the power to a unit of value, let's call it, that it makes sense for the customer? So today what we do is we link it to traffic. So the more traffic the switch is sending, the more that this is being used, we consider the more efficient use of the electricity we have. I don't know if that makes sense.
Right. So the idea is not only to know what each device consumes, but also if there's a purpose, right? If a switch can be up, but if it's doing nothing, then maybe you could shut it down, or maybe not. Maybe it's not doing much, but it's critical. So you need to know what you can shut down or reduce, right? You need to know why it's using. Okay.
Exactly. And then ideally, we would like to have this granularity saying, for example, you enable a feature. Does this increase the energy use or not? We are not there yet. I think there is, some devices you can have a better understanding. Of course, you can understand per model. That's no issue. Now, with the monitoring that we have, we could even understand the ports, right? So if you shut down the port or don't shut down the port, you can see if the consumption has actually varied, but you will not have the ability to ask the switch, okay, how much this port consumes for today, right? But I think the business unit is investing quite a lot of having this understanding and these optimizations, and we will see interesting developments and features as well coming forward.
That was another question I had in mind, that your services, right? So a lot of what you're talking about sounds like features that should be in the product, made by the business units. But is it correct to say that you're actually working with the customer to understand the needs, and then working with the business units of different products to correlate everything and make sure it works together to get a proper picture? Yeah.
Yes. So I think, it comes in different waves. So the first one is very important, is work that the team is driving also with ITF, is to have a standard to understand, well, first the power draw, the energy consumption, and then secondarily, if we could have also a standard telemetry for sustainability overall. So now in Europe, there is quite a lot of legislation coming. One that is quite interesting is the product passport as well. So the product passport will ask every company that generates IT hardware to report on certain information on how this product was made and so on. That's I'm not familiar with all the details. It's still work in progress a bit. So some of this information, it will need to be part of the data sheet, right? That's a sustainability standard. So the more I think that we can query our devices in a standardized way to understand how they are built, how this is used, what we can optimize, the better that it will be also served for our customers. And then you can get very creative, right? You could ask, why do we need to have two redundant switches really consuming power all the time? Could we actually just shut down, not shut down, but put it in saving mode, one of those? Or if you have a port channel, do you really need to have all the ports actually consuming power, or maybe just one of them will be working and the other ones would be in saving mode until they are needed? So there is quite a lot. And then cooling and the fans on the switches, the business unit is working a lot to make it more intelligent so it doesn't consume that much power as well.
I do have one side question, and maybe a bit of a tricky question if you want. As a sustainability lead, what is your take on AI, especially with regards to all the energy that it consumes, with all the data centers that are spun up to run AI feature? What do you think about that?
So I think at the end of the day, we'll need to base it as well on the benefits that it brings us, because we do know that it consumes more power. There is no question mark about that, right? But then it's always kind of different layers on the discussion. So first of all, when we create an AI model or we train it and so on, what are the steps that we need to follow to make sure that end-to-end the process is more efficient? And there is actually very interesting material or studies that are being done. Even at Cisco, I don't know if we publish them, but we have a research community. Any university can actually go there and ask for funding to do research, and I'm actually doing a PhD myself, but not in this one. But for that, I know like a bit of the world of the PhDs as well. So, and then there is also a conference I went in Stockholm, I think a couple of months ago, and the guys are really doing very, very specific testing on understanding, for example, the sets of data. And normally you would know if it's bigger, it will require more energy because it takes more time to train. But then, of course, what do you lose if you make your data set smaller, right? And then you train your models. Some of those models are really, really huge. Some are actually smaller and much more efficient. So I think when we build AI or we use AI, depending how we are consuming it, we need to make sure from the beginning to ask ourselves, can we make it more efficient? Does that make sense? And then the next step is as well the use that we have. If it increases the utilization of energy 10, 20% more, that's the benefit that brings us is also 10 or 20% more. And I think one of the interesting use cases was the Google search, right? So you could do the Google search as it has been until now, or you could do it also with AI. This does require more energy. So we are thinking, do you really need to use it with AI, or what we had has been good enough? So does that make sense? So this kind of two things. Are we actually creating value with more resources, and can we make the end-to-end more efficient?
It seems to answer a bit the contradiction I had in mind that, oh yeah, we're saying we're going green, but it seems a lot of new device generations are always consuming more electricity, and AI is consuming a lot of electricity. But it's not about necessarily the total amount of watts. It's about using electricity only when it's needed, so shutting down what can be shut down, and also keeping an eye on efficiency, right? Making sure each watt you're burning is really used for a good reason.
Exactly. So this is something that's super interesting because, of course, every customer will ask you, is that now the right time to upgrade? And I found it as interesting that I decided to do a PhD on this one. So basically, what I'm looking into is the total sustainability cost of ownership. So first, there is different ways to analyze a product sustainability or footprint, if you like. One of those, for example, is the life cycle analysis. But all of those, they are looking into the product from a product point of view, and we are services, right? So we need to look into, I think, from a customer point of view. And for me, the total cost of ownership, I thought it was, or it is, a good way to do it. So then the question that I would to ask is, okay, when is the right time in sustainability point of view to change your device, right? So is that now good enough because it's more efficient, or because, it has more power, or why is now a good time as well? And then if you are looking into the end-to-end cost, how do we quantify sustainability? So CO2 is relatively simple because you have carbon pricing and you have taxes links to it, so you can kind of put a price to carbon. But if we are looking into the social part, it's very complicated because the data center has social implications for many, many different users. The one that lives close to it, we, for example, that are using this tool online that is going to be running in the data center, a business owner that has created its own business on top of a virtual machine running in the data center, right? So there is many, I think, social aspects as well. So that's what I'm trying to understand. And then in the electricity part, the consumption, the new devices, not all of them, you have a mix, but in general, you would be right. They tend to consume more. Generally, they are more powerful and they are also smaller in size. So we need to count about everything. So if they are smaller in size, that's also good because the cooling would be less. Then in the other side, they normally may need a bit more power. So now it's becoming a bit of a challenge in the racks, in the data centers, the amount of power that you need for every rack. But I think net, what we have found is that the new devices normally would be more efficient end-to-end, especially as well if you can consolidate and modernize. A lot of times, one-to-one doesn't make sense. You really need to understand and consolidate your devices. And then the second question we always get, if you look into ICT, a phone, for example, it's actually normally more CO2 or creates more emissions when you manufacture it. But actually, an IT device, it consumes a lot of energy during the use of this product. So normally, 20% would be the manufacturing, transport, and end of life, and then 80% would be during the use. So that's basically the energy that it consumes. So, if we say, look, with the new, let's call it architecture, right? Not just one device, we can reduce maybe 40, 50% this consumption of energy, then that's actually, I think, a good case already for thinking about upgrade, if that makes sense.
What I really like is all the questions your approach is really raising, and they're really good from a even network design perspective. Before it was like, yeah, redundancy for everything, and then now you're asking, do you really need that second device standing there doing nothing all day? And we have other ways of doing, and maybe you would have a 1 second traffic gap in case something happens instead of completely zero. But is it really that critical? Sometimes yes, sometimes no. So you could save some both money, electricity, CO2 by designing differently. And then you talked about efficiency, the amount of watts per packet per gigabit or whatever. And then even beyond that, you could ask, but do you need all those gigabits? Like in your traffic, there's a lot of useless traffic, and redesigning traffic, not because we don't have good enough WAN links, but because you want to use less network traffic so that your network devices are used less. And
Yeah.
it's asking all the right questions, right? There's not one answer. The answer is going to depend for each customer, which I understand why, it needs to be in the hands of services, because you need to work with each customer to understand and make it make sense. But it sounds really interesting.
And especially you design for maximum utilization, right? You want to always have. And this is very interesting for the service providers. You would design for maximum utilization. When is the maximum utilization? Now, when everyone opens up the streaming services, whatever one it's your favorite. And it tends to be, I think, during the same time. So actually, you may design the network for these 2 hours that everyone is watching their favorite show. So yeah, the conversation needs to evolve. And we had many ideation sessions also with some of our service providers on thinking, do you may charge more for these 2 hours of high amount of traffic? And of course, with the service provider, the good thing about our SP devices is you have quite a lot of granularity. You can configure or do the cabling in a way that the module will be reducing shutting down the ASICs and just using the ones that you need to use. But you need to configure the cable properly. Of course, if the cable that you always use is the last one, so all the line card needs to be enabled, right? So anyway, but then there is a bit of a fear, of course, if you shut it down, will it come back again? You need automation as well for that. You need the right observability. So there is quite a lot of, I think, evolution and a process that needs to happen for us to get, I think, on this level of automation for sustainability, or let's say having the right capacity for the right use. And of course, in a data center, normally I think it's about 10% the networking, and then you will have most of it is gonna be the servers, and a lot it's gonna be the cooling and the HVAC and so on. Now this is going to be also regulated by the Energy Efficiency Directive. So that's something that I think we'll see more and more customers coming up to us and asking us for help, right? To make sure that the cooling is proper, that they use and so on. But yeah, the servers, the configuration of the servers, shutting down the devices. And it could be something as simple as, that was one of the use cases that was presented on this ICT for Sustainability conference, was as simple as to put a tag on your virtual machine, say it should be open during the day, it should be shut down at night, it always needs to be open, and then you can very easily automate that. So I think we're going to see quite interesting as well use cases or innovations that will happen in this area linked to, I think, mainly energy consumption, because it's going to be interesting, but of course, as well, the whole sustainability discussion.
Super interesting.
I'm very impressed by how you presented that, all the aspects, or at least some of the aspects that you're working on that I never thought about. Like, to me, it looks like an equation with so many unknowns that it should be impossible to resolve. But it looks like you have so many ideas to tackle this problem that I'm sure it will get somewhere. So it's quite impressive, actually.
Thank you, Tristan. Yeah, I mean, I've been thinking about it for a bit. It's still a bit to go, but yeah.
Well, I have so many other questions, but it will become off topic probably. So, no, I think it's great. Thanks a lot.
Cool. Enjoy. See you. Thank you, guys. Bye-bye.
Thank you.
Thanks for listening to this episode of the Cisco Tech Stories podcast. You can subscribe to us on Cisco Podcast Network and SoundCloud or in your favorite podcasting app. You can also find us on X at Cisco Tech Story without S. Thanks again for listening and speak to you next month.
In a small town off the beaten track, Esther worked with servers, cables, and racks, solving problems late into the night. Her skills shone through, she got every loop right. From switching networks to greener dreams, now she leads a team with sustainable schemes, turning plastic waste into gold fields, in a world where hope and tech can't heal. From switching networks to greener dreams, now she leads a team with sustainable schemes, turning plastic waste into gold fields, in a world where hope and tech can heal. Oh, Esther, you paved the way, from fixing loops to my global days. A Spanish heart with a tech mind key, building futures that are pure and green. Gone are the days of midnight calls, now she stands tall in corporate halls, deciding paths for eco-friendly trades, leaving behind a greener shade. Gone are the days of midnight calls, now she stands tall in corporate halls, deciding paths for eco-friendly trades, leaving behind a greener shade. From cold streams to clean valleys wide, she keeps on pushing, never to hide. An engineer with vision so clear, crafted a world we hold dear. With every conference her voice leads, in a fight for land and future needs. From dusty towns to the bustling